Course 2. We are in lesson 55, and we are going to be dealing with something kind of like what we did in lesson 54. We're still dealing with rate problems, but you notice an additional word, actually two additional things, average rate problems with multiple steps. That's where we're going today. All right. So, um, this lesson is maybe a bit confusing, but I think with a couple of examples, we'll be able to get to it relatively easily. Well, they don't give much explanation. They just jump right into the first example because they're understanding or anticipating that we know how to do rate problems, which we did in lesson 54. So if you need a reminder, go back to that lesson. So here's the first example. It says the average of three numbers is 17. What is their sum? All right, there's several ways to get an average of 17. We could do 16 plus 17 plus 18, um, and that would equal 51 over 3. And we understand that the average of both of those, okay, we're adding all three numbers and we're getting 17. That's one example. A second way to do it would be to say 10 plus 30, excuse me, 10, let me go back just a little bit, plus 11 plus 30 equals 51. And we divide by 3 and we still get 17. So what we're doing is we're trying to arrange numbers here to get to 51 over 3 so that we can achieve the answer of 17. Or we could do 1 plus 1 plus 49 equals 51 divided by 3 equals 17. Anyway, so what do we do? All right, here's something that we do know. If the average is 17, then we do know this, okay? We know that 17 plus 17 plus 17 equals an average of 17. This is guaranteed. All of these are hypotheticals, okay? So how do we know what the average is? Well, we're not told any of those things. If you notice up on top of page 387, it says, notice that for each set, the sum of three numbers is 51. Since average tells us what the numbers would be if they were equalized, the sum of the three numbers is the same as if each of the numbers were 17, 17, and 17. So even though we have weird numbers here, radically different numbers, 16, 1, 17, 11, and 1, 18, 30, and 49, it still means that each of them totaled together are going to give us an average of 17. So are all these right? Yes. Is this one right? Yes, it is. Both of them are. Okay, example one's just to begin the process of showing you that this is a little bit more difficult than just the average problem trying to come up with an average. It's not going to give you three numbers, have you add them, and divide it by 3. You're going to have to come up with an extra number. Let me show you how this works, okay? Look at example 2, and here's where we're going to get into the nitty-gritty of the lesson. It says the average of four numbers is 25. If three of the numbers are, so here's what I want to do. I'm going to list out four numbers here. Three numbers are 16, 26, and 30. And we don't know what this one is. I'm going to put N for don't know or number or whatever, okay? And in order to get an average, you remember that we add all the numbers, we get a total, and then we divide it by 1, 2, 3, 4, okay? All right, so it says, what's the fourth number? We know that the average is 25. So if we did 25 plus 25 plus 25 plus 25, we would get an answer here that would be correct. So we can use this information right here to help us solve for this number. Okay? Let me show you how to do that. All right? First of all, if we have 4 25s, we know that is going to equal 100. Okay? So we also know this. If all of these numbers are added up, including n, it should also equal 100 because the average is 25 on both sides. So now I want you to look at this equation, okay? Since we know that this whole thing equals 100, how did we find that out? Because we did this. We knew that this is correct. So what we're going to do is we're going to solve for n. All right, how do you do that? Well, 16 plus 26 plus 30 plus n equals 100. So let's add these three numbers up. Okay, let's do it easily, and let's go 30 plus 26. Okay, we know that is 56, and then let's add 16. We've got 72. All right, so this block of numbers equals 72 plus n equals 100. How can we get n by itself? Well, we can subtract 72 from this side and subtract 72 from this side. So 100 minus 72 is 28. Guess what this number is? It's 28. Okay, so all I did was I found out the guarantee. I found out exactly what those added up to. Then I added these up and put the guaranteed total here and solved for my number. Okay? So again, not too difficult, but if you don't know the process of this process right here to come up with this 100, then this process will not make any sense at all. All right, let's try another one. Let's go to example 3. Example number 3 begins and says, after 4 years, the average number of students participating in after-school sports was 89. So we know a couple things. We know 4 years, and we know 89. Okay, what does that equal? 4 times 89 equals 356. So we know that there's a total of 356. All right. The total is the same as if each number were, let me go back up to the problem. How many students must participate in the 5th year to bring the average up to 90? So we want to see this, 5 years and the average to 90. Well, what does that equal? 450. Well, what's the subtraction here? 450, actually, we'd have to do it this way. Right? 450 minus 356. What's the difference? What is that number? It would mean 94. We would get 94 students here, which means that's our answer. We would have to get 94. So it makes sense, right? If we're going to bump the average up from 89 one more to 90, this number has to be larger than 90. This is an easier problem because you don't have to do the full, 25 plus 25 plus 25 plus 25 thing. You already know 4 years, 89, 5 years to 90. You're just multiplying those out and subtracting the number, and boom, you got your 94. All right, so that's 2 ways of doing them, and I think you'll understand that pretty well. All right, example 4 is just 4 and 5 are rate problems with using money. So go to example 4. Tyrone is buying refreshments for the next math club meeting. Brand A cranberry juice is on sale for $3.20 for 64 ounces. Okay, let's write that down. $3.20 for 64 ounces. Okay, brand B costs $1.19. Wow, seems cheaper. But how many ounces? 17. All right, which is a better deal? Okay, so what we're going to do is we're going to do a division problem for each one of these. Okay, let's say we're going to take the ounces and divide them into, or by the price. Okay, we're going to come up with our answer here. We're going to do the same thing here, 17 ounces into $1.19, and come up with our answer. Well, here's what's interesting. In this case, we have 0.05. In this case, we have 0.07. So the smaller amount is more expensive. So what should he buy? He should buy the one that's 5 cents an ounce. Okay, so this one is better than this one. So he should spend $3.20 to get the better deal. All right. Example 5 is a similar thing. So you're just trying to find out which is the better deal. I think you can find that out and see that pretty easily with just example 4. All right. So if you have any questions, let me know and I'll help you.